The HOMER Pro Optimizer helps you to find the lowest cost system design. It helps you optimize the size of the PV, wind turbine, battery, and system converter components in a HOMER model. The optimizer offers four key values. 1. The optimizer makes finding results in HOMER simple. It limits the user input required, enabling you to get click and go results. 2. The optimizer makes finding the optimal design fast, particularly when you're performing sensitivity analysis across a wide range of values. And 3. The optimizer makes it easy to find all system categories. For example, it makes identifying the lowest cost 100% renewable system straightforward. And fourth, the optimizer helps you to get robust results by reducing user error when specifying the search space. Improper use of the search space was, previously, the single most common source of user error. If you want to get started quickly, you could use the wizard by clicking on the Start Wizard button. The wizard always uses the optimizer. However, you can also use the optimizer in any HOMER model you create. Turning on the optimizer in a model is easy. To show you how, we'll start with a sample file exploring wind diesel systems. To open the sample file, go to the File menu, click on Samples, and then click on the sample wind diesel system. Once the file loads, we'll start by turning on the optimizer for the battery. To do this, click on the battery and locate the small star above the search space input. When you click on the star to turn on the optimizer, it will turn orange, indicating that the optimizer is enabled. One of the unique attributes of the optimizer is that it lets you specify bounds for the component size, both upper and lower. Let's specify an upper bound of 200 batteries. For this battery and load, this is equal to about 20 hours of autonomy. Now let's turn on the optimizer for the converter and the wind turbine. Click on the converter icon on the schematic and click on the star to turn on the optimizer. Let's specify an upper bound of 300 kilowatts. Then click on the wind turbine. Click on the star to turn on the optimizer, and let's specify an upper bound of 10 wind turbines. If you don't know what value to put in the upper limit, you can always start with a large number and then run it again with a smaller number to refine the results. Now let's click Calculate to run the model with the optimizer. We can watch the optimizer as it creates graphs of net present cost as HOMER optimizes the design for each sensitivity case. You will notice that the net present cost jumps up a bit in each graph. This is HOMER Pro finding not only the overall optimal system, but also the lowest cost for each of the categories, also known as system types. Now, if you count the graphs during the calculation process using the optimizer, you'll see that HOMER runs the optimizer for each of the 20 sensitivity cases included in this model. Now that we have gotten results, you'll see that the optimizer has identified the lowest cost system for each of the 20 sensitivity cases in this model. The optimizer makes HOMER analysis simpler, faster, easier, and more robust than ever before. This innovation has major implications for how we recommend you use the HOMER software to analyze and gain insight into microgrids. A HOMER training will help you to get the most out of using the optimizer, how to adjust the settings, and what it means for using HOMER Pro.